First we will look at the geometrical meaning of a constant polynomial. A constant polynomial is polynomial with a degree 0, a non-zero polynomial with a degree 0. Example, px is equal to 0. We have already studied that a non-zero constant polynomial has no zeros. Here the graph of the polynomial px is equal to 3. It is a horizontal line parallel to x-axis, so it will never cross the x-axis. We have already studied that 0 of a polynomial is the x-coordinate of the graph which touches the x-axis. But this line never touches the x-axis, so it has no 0. Next we will look at linear polynomial. This is the geometrical meaning of 0 of a linear polynomial. General form is ax plus b. Here we have already studied that the graph of a linear expression is a straight line. So here, if coefficient of x is positive and constant term is positive, then the slanting of the line is in this way. It will meet the x-axis at the point minus b by a 0. So this is the 0 of this polynomial. Again, sometimes the polynomial may come in this way, ax minus b, the constant term may be negative. Then 0 will positive side of the x, that is b by a 0. This is the 0 of the polynomial. Sometimes the polynomial may be in this way, minus ax plus b, the coefficient of x may be negative. Then the line may be look like this, and it will meet the x-axis at b by a 0. That is the line meet the positive side of the x-axis. Here, if the coefficient of x is negative and constant term is negative, then the line will meet the negative side of the x-axis and the point is minus b by a 0. So these are all this point, and these points are all the zeros of the linear polynomial. Now we will look zeros of a quadratic polynomial. The general form of quadratic polynomial is this one, ax square plus bx plus c, and where a is not equal to 0. These are the graph of quadratic polynomial in different situations. First we will look this one. For some quadratic polynomial, the graph will cut the x-axis at two different points, and shape of this graph is called parabola. And here the opening is on upward side, and here the opening is on downward sides. This opening of parabola depends upon the value of the coefficient. Here the coefficient of x square is positive, then the opening upward. Here the coefficient of x square is negative, so opening downward. So here for two different values of x, for a particular value of x here and particular value of x here, two different values of x, this polynomial becomes 0. Thus it has two different zeros. Sometimes the polynomial, the graph of the polynomial may come in this way. Then that polynomial has only one 0. Here only one 0. Here it is also 1 0. It will not cut the x-axis, it will touch the x-axis. Then it may have only 1 0. Sometimes the graph may come in this way for a particular values of coefficients. Then the graph never touch the x-axis. Then we say that the polynomial has no 0. Quadratic polynomial has no 0. Here no 0. Here it may become in this way. In this case also it has no 0. So for a quadratic polynomial it has maximum 2 0, 1 0, and sometimes it may not have any 0. These are the three situations where a cubic polynomial touches the x-axis. Take the first case. Here the graph of a cubic polynomial cut the x-axis at 3 points, 1, 2, 3. So this cubic polynomial has 3 zeros. Sometimes the graph may come in this way. When the graph comes in this way, it will touch the x-axis at 2 points here and here. Then we say that this cubic polynomial has 2 zeros. Sometimes the graph may come in this way. It will touch the x-axis at only 1 point here. Then we say that a cubic polynomial has 1 zero. So for a cubic polynomial, maximum 3 zeros and minimum 1 zero.